Okay, so today I will introduce to you the fifth part of our lecture, the lecture series for the vectors for dumb, right? The vectors for dumb. Vectors for dumb. And in the last lecture, I had introduced to you the magnitude, the length of the vectors a plus b, the resultant of a plus b and the resultant of a minus b, right? The magnitude of these two things. So now I will introduce to you angle, just an angle in between a plus b and a, right? And a minus b with a, or something like that. Okay. So let's introduce, if it is a vector a and it is a vector b, then obviously the a plus b, actually if you just translate this a from here to there, so it is actually our new a, right? Just a new a, the same, right? I just translate this from here to there, and what will be the a plus b actually? Just connect these 2 points with a straight line, and it is called our a plus b, right? Or just name it r. Okay. Now I want to calculate angle in between a plus b, r, with a b, right? Angle in between a plus b, r, with b, right? Okay, so let's take it, the angle in between a and b is theta. I just named it O, P, Q, S here, and the angle P, O, Q is actually a theta, right? Okay, and now I want to calculate the angle with r, a plus b, this vector with OQ, the b. So just name it alpha, right? Just name it alpha. Okay. So I want to calculate the value of alpha, the angle with the vector a plus b, r with b, right? Okay, this is very simple, right? Just extend this line OQ and please drop a perpendicular from S to this extended line OQ. Just named it T somehow. Okay? It's very simple. If it is a theta, a full angle, then obviously it is a theta, because I just transferred it parallel to itself from here to there, right? Just a parallel transformation from here to there. So if it is a theta, then obviously it is a theta. And from our previous part, all of you know the ST is actually QS sin theta, and QT is actually QS cos theta. And what is QS actually? QS means the same thing, the OP, because I just transferred this vector parallel to itself, just the same length actually. So OP means QS, just the same. OP means QS, and is the length of the vector A, right? length of this vector A is the A, and the length of this vector A, I mean the magnitude of vector A, all of you know, is the modulus of A, right? Just the modulus of A. So the ST means the redefined form ST, the QS means modulus of A times sin theta here, and the QT means the QS, I mean the modulus of A times cos theta here. Okay? Okay, this is a very simple case. And I want to calculate this angle actually, the angle with A plus B and vector B. Okay? So just very simple, it is a right angle triangle here, OST. It is a right angle triangle. OST, it's a right angle triangle, and all of you know tan alpha. Tan alpha means this is the perpendicular by base, right? It's a very simple case because the tan of some angle, that means height by base. Height means perpendicular by base, and it is the perpendicular by base OT, right? And what is ST actually? ST means modulus of A sin theta. No problem here. And OT means, it is a jump here. OT means OQ plus QT, right? OT here. OT means length of OT actually. OQ plus QT, right? It is the OQ plus QT. And it is a modulus of A times sin theta by OQ. OQ means what? OQ means the length of vector B, right? It's a magnitude and the length of vector B, because it's a vector B. So obviously OQ means the modulus of vector B, I mean the length or magnitude of vector B. Very simple, the OQ means vector B plus the QT means modulus of A cos theta, right? It is our tan alpha, right? It is our next formula. Actually, if I want to calculate, or if you wish to calculate angle in between A plus B, I mean R, with vector B, is actually tan alpha. Alpha is just angle in between A plus B, I mean R, with the vector B. The alpha, the tan alpha goes to modulus of A sin theta here divided by modulus of B plus modulus of A cos theta here, right? And the theta is actually angle between A and B, right? Angle between A and B. Theta is actually the angle in between A and B, right? Angle between A and B. Okay? Tan alpha goes to here. But just look at this thing. Just look at this thing very carefully. I want to calculate the angle in between this A plus B, I mean R, with a B, right? It's the alpha. It's alpha, right? But here, the B actually a newt, right? B here a newt. The angle goes to the A actually. A times sin theta, A times cos theta. I mean, it is a A, right? Actually, I want to calculate the angle in between R and B here. A is actually, I did not want to calculate the angle with A. So here is the formula actually. B is newt. I mean, whichever I want to calculate the angle with the A plus B, this is actually newt, and another vector actually goes to with sin theta and cos theta here, right? If I want to calculate the angle with B, so B goes to newt, and another vector is actually A, and this angle of theta, I mean A and B, goes to with the A, right? So A sin theta and A cos theta. Okay, so these are very crucial results. If I wish to calculate the angle with B, then B goes to newt, and the angles, all the angles, theta actually, angle between A and B is with goes with A, right? A sin theta by A cos theta. And beta remains newt. Okay. Okay, so these are an angle in between A plus B with B, and obviously if I want to calculate the angle in between A and A plus B, the beta here, just take the name is beta, angle in between A and A plus B. So obviously by our similarity we will calculate tan beta goes to, I want to calculate the angle in between A and A plus B, then beta goes to newt. So I mean the A goes to newt, so the angle overall is a B sin theta by A plus B cos theta, right? Because I want to calculate the angle in between A and B, so A goes to newt here, and overall angle is a theta is actually with our B here, right? Just a similarity here. Okay. Okay. So now I want to calculate the angle with A minus B or B minus A, right? Okay. So just erase all of this thing here. Just remember, here is alpha. Alpha is actually angle between A plus B and B. The B goes to newt, and all these angle theta and theta here, theta is actually angle between A plus B, goes with A, right? Similarly, if I calculate angle between A and A plus B, so obviously A goes to newt here, and then with the angle of B here, B sin theta by B cos theta, right? Okay, so it is our the angle in between A plus B with B and A. Now I wish to calculate, or I want to calculate angle in between A minus B or A plus B with A and A minus B with A and B, right? Okay, so first of all, we'll draw the vector A and vector B, right? So it is our vector somehow A, and it is a vector B. Okay. Okay. So you want to calculate first of all what is A minus B actually, right? So A minus B actually, just all of you know from our previous classes, is actually A plus of minus B. So same thing actually. Plus minus means minus. Say plus of minus B means say minus B. It's very simple. And if it is a B, so this is actually our minus B, right? The length is actually the same, but the direction is opposite, right? It is a minus B. Okay. And just translate this minus B from here to there. Right? This is actually our minus B here. And now I want to calculate A plus minus B. I mean addition of this with this vector. And all of you know how to add these two vectors. Just translate this thing from here to there. Right? It's very simple. It is our new A. and just connect these two points with a straight line. So it is our A minus B. Okay. Just A plus or minus B means A minus B. And now translate this from here to there. It's a very similar. It is a parallel transformation and it is actually permissible for our calculation. It is A minus B. Okay. Remember the direction. It is A minus B. Okay. So I will erase all of these things. Okay. Now I want to calculate angle in between A minus B with a B. I want to calculate the angle in between A minus B with B. Right? Okay. Just extend this line here. It is a vector B. Just name it is a theta here, just a normal. If A and B is the angle theta, then obviously it is our, just named it alpha, right? Angle in between A minus B here, and it is a B. The direction of B is there. The angle in between A minus B and B, just take it alpha. So obviously it is actually R180 minus alpha, right? It's just a very simple case because the full angle here is a 180, is a alpha, is a 180 minus alpha, right? And I just drop the perpendicular from here on this point, on this straight line. Just name it T. Okay, it's a O, it's a P, is a Q, is a T. Now it's the right angle triangle here. Okay, first of all, the OQ. OQ means the length of vector B, right? So OQ means length of vector B. I mean the magnitude of vector B. And OP means the length of vector A, right? I mean the magnitude of vector A, it's a OP, right? And I want to calculate angle in between A minus B with a B, just alpha here. Okay. Okay. So if it is a alpha, then it is a 180 minus alpha. So obviously from our PTQ, triangle PTQ, right? This is a right angle triangle, and obviously the tan of 180 minus alpha goes to, just a very simple thing, perpendicular by base, right? PT by base QT. And what is a PT actually? Is a PT means is a right angle triangle of POP. All of you know the PT means modulus of A sin theta, and OT means modulus of A cos theta. Okay, is the just a PT means modulus of A sin theta here, and QT, that means this length actually goes to the full length OQ minus OT, right? The QT means OQ minus OT, right? So OQ minus OT is the modulus of A sin theta, and OQ goes to modulus of B here, minus OT means here modulus of A cos theta. It is a tan 180 minus alpha, right? So it is our angle in between A minus B with B, right? It's a very simple case. Okay, so this is all about the angles. And if you want to calculate the angle between, is a very interesting formula here. Just note it. Okay. Similar, just a similar thing, because I want to calculate the angle with B, right? B with A minus B. So B goes to nu here, and A here, A sin theta by with A cos theta, right? So all of these angles just on the A. B goes to nu because I calculate the angle with B. Okay, so B goes to nu here. No problem. Just same. Okay. Very simple. Okay, so now I want to calculate angle in between B minus A with B. Okay, B minus A with B. Okay, so I erase all of these things here. Okay, so I want to calculate. Suppose it is our A, vector A. It is our vector B. I want to calculate the B minus A here. Right? And obviously B minus A means B plus minus A. Just a very simple. Okay. Because the same thing, right? Plus minus means a minus sign here. And what will be the minus A? If it is an A, then obviously the minus A goes to this thing. And just translate this minus A from here to there, right? Just a parallel transformation. It is your minus A, right? Just add this B to the minus A. Just add these two vectors. Very simple, all of you know. Just add this thing with this. I mean, just parallel transformed from here to there. Right? Just a parallel transformation. This is your minus A. Just connect these 2 points here. Right? It is our B minus A. Right? Okay. So now I want just erase all of this thing here. Just erase. I want to calculate the angle in between B minus A with B. Okay. I want to calculate the angle with B minus A versus B. Right? Okay. And just take it. It is an A and theta here. Okay. So just name it O P Q S and just draw a perpendicular from this point to this point. Okay. This is a vector B. Just a perpendicular, so name it T. Okay. And just OP means the vector A. I mean the length of this vector A. OQ means the length of the vector B. Okay, is the OQ. And obviously OP and SQ is the similar, right? Because I just transfer it parallelly and then transfer from here to there. Right? So actually the length of OP and the length of SQ are same. Is the modulus of A, right? Okay, now it's a very simple case. If it's a theta, then it is obviously a theta, right? Because I just transformed it parallel to itself here. Okay. It is just an alternate angle. If it is theta, then it is theta. But I want to calculate here angle in between B minus A with B. Here, angle between B minus A with B. Just name it alpha here. Right? Okay. And just for the drawing, it's a perpendicular. So obviously, the ST goes to is a SQ sin theta and QT goes to SQ cos theta, right? And obviously the SQ actually, SQ means this length is A, right? Here, so A sin theta, and SQ means, I mean the QT means here SQ cos theta, that means modulus of A cos theta. Okay. Okay, so now I want to calculate this angle. I mean the angle between B minus A with B. Okay. Just take here is a, I mean the right angle triangle here. Just take the tan alpha. Right. Tan alpha goes to OT by ST. OT by, oh sorry, is a tan means height by base, right? I mean ST by OT. Okay. The ST by OT. ST means here SQ sin theta, that means modulus of A sin theta, and OT. OT means OQ, the full length of this thing, OQ minus TQ, right? OT means OQ minus TQ. Okay? OT means full length OQ minus TQ. So OQ minus TQ means modulus of A sin theta over OQ means, all of you know, it is a vector B. That means the length of vector B. That means the modulus of B here minus TQ. TQ means here QT, modulus of A cos theta. It's the angle between B minus A with B. And just like this stuff, please look at this stuff here. I want to calculate the B minus A with the angle in the vector B is alpha, right? But the B actually goes to nu here, and it is the A sin theta by A cos theta. Okay, it is a very simple case, right? Very simple case. Okay, so it is all about our angle between A plus B with B, A plus B with A minus B with B, A minus B with A, and it is the last case, B minus A with A or B minus A with B, right? It is a very crucial here, and a very simple trick. If you want to calculate B minus A or A minus B or A plus B with a B, then just B goes to newt, and all this angle actually for the A plus B actually goes to, I mean if it is a plus B versus B, so tan alpha is actually angle in between B and A plus B is actually A sin theta by B goes to newt plus A cos theta, right? Because I want to calculate the angle in between A plus B and B. So B goes to newt, and all these angles with A, and all of this just preceding here. I want to calculate B minus A with B, so B goes to newt here, and A sin theta minus A cos theta. And if I calculate the B angle between A minus B with B, same will happen. So B goes to newt, A sin theta by B minus A cos theta, right? So these are all of these things here. Okay. So now I want to calculate, I mean it is our last part of this part 5. Last session of our part 5 is a multiplication of a vector, right? The multiplication of our vector. Okay. Okay, so just I just want to introduce the multiplication of vectors in our next class, the two rule, actually the product of two vectors, it has a two rule in the dot product and the cross product. Just I introduce to you the next class, right? Okay, in the next class I just introduce to you, I'll introduce to you the two product rule of vectors, and then I will turn to our algebraic representation of vector, because all of these things I just did in our part up to our part 6, and it's a part 5 lecture, and then I'll introduce to you part 6 with the product rule. So up to our part 6 I will introduce to you, I had introduced to you the geometrical interpretation of vector, and then I'll introduce to the algebraic representation, right? Then you are probably, probably you're pro, right? Probably you'll be a pro with vector. Okay, okay, so these are end, right? Please do like, share and comment.